Hello everyone, our project is 2 Sigma using news to predict stock movements. This is the outline of our presentation. Our project is a cargo competition held by 2 Sigma. The goal is to predict the stock price movement for the next 10 days for given assets. We aim to predict the Y variable, which is between -1 to 1, containing direction, meaning whether the stock price goes up or down, and confidence. If RTI is positive, we want the YTI to be as large as possible, and vice versa. We formulate the problem as a binary classification one. Our dataset contains 2 sources of data, market data and news data. We aggregate them based on asset and time. The workflow contains 6 steps. At first, we just implemented the baseline, and gradually we added cleansing, feature engineering, and normalization phase. As shown in the picture, our model performance is going better and finally achieved top 15% in the competition. For market data, we performed EDA on it, and first we pull out the closing prices of 10 random assets for all the years to show the long-term trends for them. And next, to further explore the market performance, we plot the trends of closing prices by quintiles over the years. And we can see that there are 4 serious fluctuations from 2007 to now. Those are abnormal market phenomena, such as the collapse of Lehman Brothers, Black Monday, etc. And to further investigate our target variable, we plot the trend of the variable, and we also plot the trend of other market-related values. As shown in the picture, we can see that there are fluctuations around 2008. So we just filtered out those data and plot the trend of means after 2010. We can see that there are few fluctuations, so we only use data after that for training. Next, we plot the top 10 months by standard deviation of price change within a day, and we found that there is a unreasonably high price change around 2010, but actually there is no huge market variation at that time. So after investigation, we found out it's indeed wrong data, so we replace it with mean value of other days, and finally the plot seems normal now. And there is also a zero plateau on some features around 2016, which is due to unknown data as asset name. So we filtered out the ones with unknown asset name, and finally the figure is normal. For news data, we can see the news with sentiment word count equals to 250 and 2000 has the highest relevance from the following figure. For the news with a 100% sentiment ratio, the relevance can be either low or high, and for the news with highly relevance, the sentiment ratio can vary from 0 to 1. As for the most often case, the news is both low in sentiment ratio and relevance. For correlation diagram, we use it to conduct feature selection. We only consider one feature in the pairs with high correlation coefficient, such as the novelty count in 24 hours, 3 days, 5 days, and 7 days, the volume count in 24 hours, 3 days, 5 days, and 7 days. In feature engineering phase, we added interactions between predictors through addition, dividend, so we formulated those new predictors. We also applied domain knowledge from time series analysis and technical analysis to calculate those index as shown below. Moving averages, MA, is the mean of a window time frame. It is useful to smooth short-term fluctuations and compare with a trailing moving average. Exponential moving average, EMA, is the exponential version of MA. These scores can be calculated through the following formula. And the figure here shows the trend of those features of the opening prices. We also formulate MACD, moving average convergence divergence, which is the EMA of 12 days minus the EMA of closing price of 26 days. It is useful to represent fast short-term movement, while the signal line can be calculated using EMA of DIF index of 9 days, and it is useful to represent slow long-term movement. MACD histogram can be constructed by MACD minus the signal line. The following figures shows the trend of closing price of Apple Company, and the picture on the right shows the trend of those features. For news data, we encoded the news headline by applying TF-IDF to vectorize it, and we visualize the result by using Tesny to show the TF-IDF vectors, and the clustering result is shown on the right. For modeling, we use LET-GBM, which is a gradient-boosted tree algorithm combining the predictions of multiple decision trees to make predictions that generalize well. It uses leaf-wise growth strategy. LET-GBM is actually the top choice for cargo computation recently because it's efficient and can handle categorical data well. Here we present the experimental result. We use the loss curves as our objective function. We split the data after 2010 into training set and validation set based on time, since it's time series analysis, and we feed them into LET-GBM to train, and we can see that the log loss decreases as many iterations, and we can see that after 100 iterations, the loss of validation set is actually not changing too much. And this is the predicted confidence plot of our result. And because the score is actually relevant to the mean and the standard deviation, so we can apply some post-normalization to help the performance. And we can see the scaled predicted confidence in the red picture. This is our tree visualization. And this picture showing the feature importance. We can see that most of the news features are irrelevant, while the domain knowledge market features such as MA, EMA, MACD are far more important. And among the news features, the most important one is the TF-IDF score of the headline. Our conclusions from this project is that in the financial industry, there is efficient market hypothesis, which states that price reflects all available information and should react instantly to relevant news. But everyone in the market also seen the news and adjusted their actions accordingly. So this will change the open price, and absent of any drift, the price will not change further. After this point, any further shifts in price over the next 10 days will be unrelated to the original news. So in short, when the news article comes out, we are already too late. The above theorem corresponds to our discovery that news are not relevant. And we also found it's helpful to apply domain knowledge to do the prediction. And data cleansing is important. Next, in the future, perhaps we will try out different aggregation strategy.